Welcome to the student the brand. So myself I'm Siva sir. Today we are going to discuss about electric current CBSE grade 10. I hope it is very clear to you all. So now we will discuss electric current. So everybody welcome to the class. Welcome to the class. Welcome to the student the brand. Welcome to the student the brand. I hope it is very clear to all. So myself I am Siva sir. Yes. So welcome to the student the brand. La, electric current. Electric current. Come on, everybody, join to the class. Today we are discussing important topic. Electric current. Electric current. The introduction must be in a bigger way. Electric current. Electric current. Myopia, 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 myopia. Near distance we can see far distance we can see myopia, myopia. Myopia, 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 myopia. Near distance we can see vacancy. Myopia, 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 myopia. For that correction, we are using concave lens, concave lens, concave lens, concave lens. Myopia, myopia, myopia. Near distance we can see. Far a distance we can see. Myopia, myopia, myopia. For that correction we are using, bro. What, bro? For that correction we are using concave lens, concave lens, concave lens, concave lens. Hypermetropia, 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 hypermetropia. Far distance we can see, near distance we can see. Hypermetropia, 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 hypermetropia. For the correction, we are using convex lens, convex lens, convex lens, convex lens. Hypermetropia, hypermetropia, convex lens, convex lens. Hypermetropia, hypermetropia, convex lens, convex lens. Hypermetropia, hypermetropia, convex lens, convex lens. Hypermetropia, convex lens, hypermetropia, convex lens. Okay, so until here, so we're discussing about until here. So we discussed about this is about myopia, hypermetropia songs, whatever I created. So now next one more I'm doing, one more I'm singing. That is new Cartesian sign convention, new Cartesian sign convention. All distance measured from the pole. Distance positive along the eccentric. Distance negative opposite to eccentric. Distance positive above the principal axis. Distance negative below the principal axis. New Cartesian sign convention, new Cartesian sign convention. All distance measured from the pole. Distance positive along the eccentric. Distance negative opposite to eccentric. Distance positive above the principal axis. Distance negative below the principal axis. New Cartesian sign convention, new Cartesian sign convention. All distance measured from the pole. Distance positive along the eccentric. Distance negative opposite to eccentric. Distance positive above the principal axis. Distance negative below the principal axis. New Cartesian sign convention, new Cartesian sign convention. All distance measured from the pole. Distance positive along the eccentric. Distance negative opposite to eccentric. Distance positive above the principal axis. Distance negative below the principal axis. New Cartesian sign convention, new Cartesian sign convention. Okay, so everybody, welcome to the class. Now we are going to discuss about. Now we are going to discuss about. Now we are going to discuss about electric current. Electric current. CBSE Grade 10 Physics. CBSE Grade 10 Physics. In this topic, so we'll completely discuss about what is current, what is current, what is electric current, what is a conventional current. So after that, electric circuit, potential difference, electrical potential, and next one we are going to the Ohm's law. After that, resistance depends on length, area, and resistivity. Difference between resistance and resistivity. After that, we will go through that. See, resistors are connected in series combination. Resistors are connected in parallel combination. After that, resistors are series, resistors are parallel. Next one, heating effect of electric current. And the next one, last one we will discuss about. Last one, heating effect of electric current. Heating effect of electric current. These points we are going to discuss. So we'll start now. Okay. So let's start. So don't waste the time. So let's get into the start. Let's get into the topic. So normally if you are taking electric current is nothing but I equal to Q by T. I equal to, so Q by T I am considering I equal to electric current. Electric current. Electric current is nothing but I equal to Q by T. I equal to Q by T. I equal to Q by T. I is the current. Q is the charge. I is the current. Q is the charge. So we can take, you can consider here. So I equal to Q by T. SI unit of current is ampere. SI unit of charge is coulomb. SI unit of current is ampere. SI unit of charge is coulomb. SI unit of time is second. SI unit of time is second. So now we are considering SI unit of charges. So I am considering SI unit of current is ampere. SI unit of current is ampere. SI unit of charge is coulomb. SI unit of charge is coulomb. So I am considering here SI unit of charge is coulomb. And SI unit of time is second. So 1 ampere equal to 1 coulomb per 1 second. 1 ampere equal to 1 coulomb per 1 second. So CBSE Grade 10 Physics. So 1 ampere equal to 1 coulomb per 1 second. 1 ampere equal to 1 coulomb per 1 second. 1 ampere equal to 1 coulomb per 1 second. 1 ampere equal to 1 coulomb per 1 second. We are considering now. Here you can see. So 1 ampere equal to 1 coulomb per 1 second. 1 ampere equal to 1 coulomb per 1 second. 1 ampere equal to 1 coulomb per 1 second. 1 ampere equal to 1 coulomb per 1 second. So 1 ampere is defined as 1 coulomb of charge flowing through unit cross section area. 1 coulomb of charge flowing through unit cross section area per second. 1 coulomb of charge. 1 coulomb. So 1 ampere equal to 1 coulomb of charge flowing through unit cross section area per second. 1 ampere is defined as 1 coulomb of charge flowing through 1 ampere is defined as 1 coulomb of charge flowing through unit cross section area per second. So that is nothing but 1 ampere. So now you are considering here that is nothing but 1 ampere is defined as 1 coulomb per 1 coulomb per 1 second. 1 coulomb per 1 second. So that is about electric current. Okay, next one. So SI unit current is 1 ampere. So ampere is defined as 1 coulomb per 1 second. Next one. So we'll go to the electrical appliances. With that we can discuss remaining thing. Electrical appliances. Okay, directly I am explaining electrical appliances. If you take electrical appliances, so this is a part of the teaching. So whatever we are discussing, that is a part of the teaching. So it is a part of the teaching, that's why. So you can see this. So my education qualification. So now I am considering here. So first one is cell. First one is cell. First one is cell, positive terminal, negative terminal. Second one is battery. Second one is battery. So positive terminal, negative terminal. Third one is switch. Third one is switch. So this so I am considering this open switch. This open switch, and fourth one is closed switch. This is a closed switch. This is a open switch and closed switch. And fifth one you are taking resistor. This is the resistor. And the sixth one is rheostat. Rheostat we can take like this or like this also. Like this also we can take resistor. And the seventh one is ammeter. Ammeter. Ammeter, positive terminal, negative terminal. Eighth one is voltmeter. Voltmeter. Positive terminal, negative terminal. Next one is ammeter, voltmeter. So next one we can go for wire joining. Wire joining. And 10th one wire crossing. Wire crossing. Wire crossing. And 11th one is bulb. So bulb symbol, bulb. This is a bulb. Okay, so this is a bulb symbol. So here you can see this is the cell. So here you can observe here. So this is the cell, battery, open switch, closed switch, resistor, and rheostat, ammeter, voltmeter, wire joining and wire crossing, the bulb. Okay, so I hope it is clear to you all. I hope it is very clear to you all. So this is about we are discussing about all these electrical appliances, cell, battery, switch, open switch, closed switch. This is about resistor, rheostat, ammeter, voltmeter, wire joining and wire crossing, and this one you are considering the bulb. This is I am considering the bulb. Okay, these are the electrical appliances I am considering. These are the electrical appliances. Now we are going to the one more. Now we will discuss about electric circuit. Electric circuit will discuss now. Electrical circuit. Okay, electrical circuit. Electrical circuit is nothing but, so here electric circuit, a continuous and closed path of an electric current. Electric circuit. So if you are taking here, if you are considering here, as I said, electric current. So electric current is nothing but electric circuit is nothing but so here you can see I am taking this the battery. I am taking the switch here. I am taking, okay, switch I am considering like this. So ammeter I am taking. Next one bulb I am considering. Next, that is connected to here. So current is passing through here. Positive terminal, negative terminal. This is the bulb. Bulb is glowing. You can observe here a continuous and closed path of an electric current. A continuous and closed path of an electric current is nothing but electric circuit. A continuous and closed path of an electric current. So you can see when the current is passing through here. So when the current is passing, so current under here, two more points I will discuss. A continuous and closed path of an electric current. A continuous and it is a closed path. A continuous and closed path of an electric current. A continuous and closed path of an electric current is known as a continuous and closed path current is known as an electric circuit. I hope it is very clear to you. A continuous and closed path of an electric current. A continuous and closed path of an electric current is known as what is that? Electric circuit. Electric circuit. Okay. So here I am considering now. So a continuous and closed path of an electric current is known as electric circuit. Okay, electric circuit. So this is about electric circuit I am considering. Electric circuit. Okay. So a continuous and closed path of an electric current. A continuous and closed path of an electric current is known as electric circuit. Okay, so that is about electric circuit. Here we can say normally there are two types of currents are there. One is electric current. First one is electric current, and second one is conventional current. Conventional current. So what is the difference between conventional current and electric current? Normally, before finding proton, neutron, electron, already scientists were given the statement. The scientists were given the definition. The flow of positive charges. The flow of positive charges is known as electric current. Is known as conventional current. Because actually after knowing the electron, proton, so we can understand current to electrons because of the electron movement only. Because of the electron movements only, current will pass in the circuit. Because of the electron movements only, current will pass in the circuit. Normally if you are taking the flow of positive charges, already they given, even in our textbooks also we are mentioning current will pass from positive terminal to negative terminal. Current will pass from positive terminal to negative terminal. Current will pass from positive terminal to negative terminal. Current will pass from positive terminal to negative terminal. So already they given the statement. But so if you are changing that statement, enter all the experiments, all the whatever the inventions or whatever they made, so everything will be again so it won't be useful. So again we have to modify that one. So instead of doing all those works, better we can change the definition. Like that. So that is the reason. So the flow of positive charges will be considered as a conventional current. The flow of positive charges will be considered as a conventional current. The flow of positive charges will be considered as a conventional current. The flow of positive charges will be considered as a conventional current. The flow of electrons is considered as a electric current. The flow of electrons is considered as a electric current. So conventional current is nothing but the flow of positive charges. Electric current is nothing but the flow of negative charges. Okay. So here the direction of conventional current is taken as the direction of flow of positive charges from positive terminal to negative terminal. So electric current is nothing but the flow of electrons from negative terminal to positive terminal. So positive terminal have high potential. So negative terminal have low potential. So positive charges will move from high potential to low potential. Whereas so electrons will move from low potential to high potential. So positive charges will move from high potential to low potential, means positive charges to negative charge. So like positive terminal to negative terminal. So electrons will move from negative terminal to positive terminal. So that is about electric current, and that is about electric currents we are discussing. Okay, so electric current and conventional current. So two currents will be there. So definitely one question will come from these two. Once again, so the flow of positive charges. So if the charges are moving from positive terminal to negative terminal, that is conventional current. So electric current is nothing but flow of electrons. Negative terminal to positive terminal. So that is nothing but and that is nothing but electric current. So I hope it is very clear to you. I hope it is very clear to you. So this is about electric current and conventional current. And next one, we will go to the potential difference, potential difference and electrical potential, potential difference and electrical potential. So coming to the electric circuit, a continuous and closed path of an electric current is known as electric circuit. A continuous and closed path of an electric current. A continuous and closed path of an electric current is known as electric circuit. Okay. So now we are considering the potential difference, potential difference, potential difference, potential difference, and coming to the electrical potential, so electrical potential, so potential difference and electrical potential. So coming to the potential difference, so here within the conductor, so I'm taking here this is a positive terminal and here point to point A to point B, so positive charge is there. So we are doing some work. So we are doing some work to bring positive charge from one point to another point. Here you can observe we are doing some work. We are doing some work to bring. We are doing some work to bring. We are doing some work to bring the positive charge. We are doing some work to bring the positive charge from one point to another point. We are doing some work to bring the positive charge. We are doing the work. So to bring the positive charge from one point to another point, within the conductor, within the conductor is called potential difference. We are doing some work to bring unit positive charge from one point to another point, that is called potential difference. Potential difference is nothing but work done to bring unit positive charge, work done to bring unit positive charge, work done to bring unit positive charge, work done to bring unit positive charge from one point to another point within the conductor. The work done to bring unit positive charge from one point to another point within the conductor is known as potential difference. So V equal to W by Q. So V is the potential difference, the W is the work done, Q is the charge. So SI unit of potential difference is volt. SI unit of potential difference, now we are taking SI unit of potential difference is volt. SI unit of potential difference is volt. SI unit of work is Joule. And SI unit of charge is Coulomb. So I am considering here SI unit of work is Joule. So definitely I am taking here SI unit of work is Joule. SI unit of charge is Coulomb. SI unit of potential difference is volt. So here you can consider SI unit of potential difference is volt. SI unit of work is Joule. SI unit of charge is Coulomb. So once again, SI unit of potential difference is volt. SI unit of work is Joule. SI unit of charge is Coulomb. 1 volt is defined as 1 Coulomb. 1 volt is defined as 1 Joule of work is done to bring 1 Coulomb of charge from one point to another point. So 1 volt is defined as 1 Joule of work is done to bring 1 Coulomb of charge from one point to another point. So 1 volt is defined as 1 Coulomb of charge. So 1 Joule of work is done to bring 1 Coulomb of charge from one point to another point within the conductor. If it is within the conductor, is called potential difference. Okay, so SI unit of potential difference is volt. SI unit of work is Joule. SI unit of charge is Coulomb. So 1 volt, see 1 volt again I am taking 1 volt is defined as 1 Joule of work is done to bring 1 Coulomb of charge from one point to another point. So that is nothing but 1 volt. So 1 volt. So again, potential difference, last and final, I will explain. Just we will go to the next one. Potential difference means you have to remember one thing. Potential difference everyone. So I welcome to the class, student in the brand. So we are discussing electric current, CBSE grade 10 physics. So potential difference is nothing but 1 volt is defined as 1 joule of work is done to bring 1 coulomb of charge. 1 volt is defined as 1 joule of work is done to bring 1 coulomb of charge from one point to another point, 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 from one point to another point. So here I am considering here. So 1 volt is nothing but 1 volt is defined as, if they ask in the exam what define 1 volt, define 1 volt. 1 volt is defined as 1 joule of work is done to bring 1 coulomb of charge from one point to another point, from one point to another point, from one point to another point. That is nothing but, so 1 volt. So whereas that is nothing but potential difference within the conductor. So potential difference means you have to keep in mind within the conductor. If within the conductor is taking place, within the conductor if it is happening, that is potential difference. Within the conductor it is happening, that is a potential difference. Whereas so if the work is done to bring, so I am taking this the infinity. So this is the infinity, positive charge I am taking. So this is the required field. So we are doing some work so positive charge from infinity to the required field, from infinity to the required field. So you are considering work done to, so V equal to W by Q. So we are doing some work to bring unit positive charge, from infinity to the required field, So we are doing some work to bring unit positive charge, from infinity to the required field, This is the required field. So what are the field is required? So from here we need to bring the charge from infinity somewhere else. So from that point to here, that is called electrical potential. So here the difference between electrical and potential and the difference between potential difference and electrical potential is only the definition. Here we are doing some work to bring Okay, so unit positive charge from one point to another point within the conductor. So work done to bring unit positive charge from one point to another point within the conductor. Is called potential difference. Work done to bring unit positive charge from infinity to the required field. That is called electrical potential. I hope it is very clear between potential difference and electrical potential. So as it is here, if the straight wire if you are considering, if the current, so here I am considering two beakers. I will tell one example. So here I am considering, okay, so one example I will tell how we are considering potential difference. Okay, so if you are considering, so these are the two beakers. If you connect so beaker to beaker like this, water is filled until the water is filled. So here I am taking water is filled until the top water is filled. So I am telling, just listen. So listen carefully here. Water in two beakers. I fill the water in two beakers. I am taking two beakers. I fill the water in two beakers at the equal level. Will the water will move from A to B? No. Water will not move from A to B. Because so they are at same level. There is no difference. There is no pressure difference. Okay, there is no pressure difference. That is the reason water will not move from point A to point B. So water will not move from point A to point B. So if I same case I am taking one more case I am considering. So if you are taking beaker at certain height, so I am considering the beaker at certain height like this. So beaker and one more beaker like this. So supporting I am taking here also support. Okay, certain height. I place. So then like this I'm taking. Okay. So here the water is filled. The water is filled. Okay. Here also water is filled. Some half of the certain height. Okay. Certain distance of water is filled. Here also certain distance water is filled. So if you connect these two beakers, okay. So if you connect these two beakers, what happens? Water will flow or not? Water will flow or not from beaker A to beaker B? Water will flow from beaker A to beaker B? Yes, absolutely. From beaker A to beaker B, the water will flow. From beaker A to beaker B, the water will flow because some difference is there. Some height difference is there. Some height difference is there. That is the reason water will flow from okay. So beaker A to beaker B. So in the circuit also, battery creates the difference. Battery creates that pressure difference. So high potential to low potential. Charges will move from high potential to, like if you are taking the positive charges will move from high potential to low potential. Where electrons will move from low potential to high potential. So who will create the difference? Battery will create the difference. So that is example. That is a potential difference. Yeah, before I explained about so potential difference, electric current we are talking about, electric current we are considering. So potential difference we are considering, potential difference. I hope it is very clear. So next one, we can go for one more. I'm considering. So electromagnetic charges. So without current also it will flow from one point to another point. Magnetic field, with the help of magnetic field, electromagnet. So by mutual induction. So like that we can say. So I'm talking about potential difference and electrical potential completed. So electrical appliances symbols also completed. Next one we are going to the Ohm's law. So we'll discuss about Ohm's law. So Ohm's law I will discuss Ohm's law. Okay. So Ohm's law, if you are considering Ohm's law I will take. What is Ohm's law? So Ohm's law. If you are taking Ohm's law, right? So the potential difference across a given metallic conductor. So I'm taking this a resistor. Okay, so resistor I'm considering here. Resistor like this. This is the resistor. I'm taking this cell open circuit. And next one we are taking the ammeter. I'm considering like this. Next one, so this is about cell. So 4 cells. I'm taking here, current is passing. Now if you are connecting like this, current is passing. So across this one we are connecting the voltmeter. Voltmeter is a device. So here you can see voltmeter is a device which measures the potential difference across a given metallic conductor. So ammeter is a device which measures the electric current. So this is a positive terminal, negative terminal. Current is passing, positive terminal, negative terminal. Current is passing here. Now here positive terminal, negative terminal. So here you have to connect in this way. This is the key. So you have to connect in such a way that so positive terminal of the battery connected to the positive terminal of the ammeter, and so negative terminal of the ammeter to positive terminal of the voltmeter. So once again, positive terminal of the battery to positive terminal of the ammeter, and ammeter negative terminal to the voltmeter positive terminal. Ammeter negative to voltmeter positive. So current will start flowing. Okay. So current will start flowing. So like this. I hope it is very clear now. Current is passing and here it is passing. So across this one we are connecting like this. Okay, so we are connecting in this way. Okay. So what is the Ohm's law? Ohm's law definition is the potential difference across a metallic conductor. The potential difference. So here you can see this is the resistor. So I am taking this is the X and this is Y. So the potential difference across the resistor, is directly proportional to current flowing through it. The potential difference across the resistor, or the potential difference across a given metallic conductor, is directly proportional to current flowing through it. The potential difference across a the given metallic conductor. So across the ends of the, so the potential difference across the ends of the given metallic conductor, metallic conductor is directly proportional to current flowing through it. Is directly proportional to current flowing through it. V is directly proportional to I. V equal to IR. V equal to IR. So V equal to IR I am considering. V equal to IR. So Ohm's law gives the definition of resistance. 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 Once again I'm saying the potential difference across the ends of the given metallic conductor. The potential difference across the ends of the given metallic conductor is directly proportional to current flowing through it. Is directly proportional to current flowing through it. So the potential difference across the ends of the given metallic conductor, the potential difference across the ends of the given metallic conductor, so is directly proportional to current flowing through it. V is directly proportional to I at a constant temperature. So very important, at a constant temperature only we have to take, at a constant temperature only. So Ohm's law, that is about ohmic conductor. So ohmic conductor at a constant temperature, the potential difference, here you can see at a constant temperature, the potential difference across the ends of the given metallic conductor is directly proportional to current flowing through it. V is directly proportional to I. V equal to IR. So Ohm's law gives the definition of resistance. 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 So V is directly proportional to I. V equal to IR. Next one, that is about statement. Next one, materials required. So materials required. What are the materials required? So what are the materials required? You can see first one I am considering 4 cells. How many cells are required? 4 cells. 4 cells are required. Okay, 4 cells are required. So that is 4 cells. 4 cells are required. 4 cells. So 1.5 volts each. 1.5 volts each. So I am taking this 1.5 volts. 1.5 volts. 1.5 volts, 1.5 volts. Each cell potential difference is 1.5. This cell also 1.5. This cell also 1.5. This cell also 1.5. Each cell potential difference is 1.5. And coming to the next one, nichrome wire. Nichrome wire I am taking. Nichrome wire is an alloy of. So nichrome wire is an alloy of nickel, chromium, manganese and iron metals. Nichrome wire is an alloy of nichrome wire. I am taking nichrome wire. Okay, so nichrome wire is an alloy of 0.5 meter. Nichrome wire is an alloy of nickel, chromium, manganese and iron metals. So nichrome wire is an alloy of nickel, chromium, manganese and iron metals. So nichrome wire is an alloy of nickel, chromium, manganese and iron metals. Manganese and iron metals. Okay, the current is passing through. So now next one. So third one you are considering. If you are taking, here you can consider. So ammeter I am taking. Ammeter. And next one, fourth one is voltmeter. I am taking. Voltmeter. And fifth one is ammeter, voltmeter, key. So that is nothing but switch I can take. Switch. So here switch I connected. Switch. Okay. Next one we are going to the battery. So I am going to the battery. Sixth one is battery. Okay, understood. So I hope it is very clear. These are the points. Once again, what are the required materials? Here? So we required 4 cells. 1.5 volts each. So each cell is 1.5 volts. 1.5 volts. Each cell is 1.5 volts, 1.5 volts, 1.5 volts, 1.5 volts. So each cell potential difference is 1.5 volts each. So next one we are taking the nichrome wire. Nichrome wire is an alloy of of nickel, chromium, manganese, and iron metals. Nichromere is an alloy of nickel, chromium, manganese, and iron metals. Nichromere is an alloy of nickel, chromium, manganese, and iron metals. Nichromere is an alloy of nickel, chromium, manganese, and iron metals. Nichromere is an alloy of nickel, chromium, manganese, and iron metals. Okay. So nickel. Now you are considering ammeter, voltmeter, switch, and battery. Ammeter, voltmeter, switch, and so anyway, battery we are considering the battery in but so that only 4 cells only, right? 4 cells only bit. So that is only battery. Connecting verse. The last one is connecting verse. So we can go with the connecting verse. Sixth one is connecting verse. Connecting verse. Connecting verse. Okay. Connecting verse. Connecting verse. I hope it is very clear. I hope it is very clear. Once again you can check. Once again you can check what are the materials required. What are the materials required here? What are the materials required? What are the materials required? First one, 4 cells, 1.5 volts each. Nichromere is it is an alloy of nickel, chromium, manganese, and iron metals. Ammeter, voltmeter, switch, and connecting wires. So these are the connecting wires. These are connecting wires. Okay. Next one you can see procedure. Procedure. So how to what is the process? What is the process? So procedure is first you have to take procedure. So procedure I am taking. Procedure I am considering. First you have to connect one cell. First you have to connect one cell and note down the reading of ammeter and voltmeter. First you have to connect one cell. Okay, so one cell, and note down the reading of ammeter and voltmeter and mention in the tabular form given below. So this is a tabular form, whatever I am writing, this is a tabular form. So you are considering serial number of cells, ammeter, voltmeter, so V by A. So you have to take 4 readings. So 1, 2, 3. Okay, so one serial number. Okay, number of cells, ammeter reading, voltmeter reading. So V equal to IR, right? V equal to IR, I equal to, so R value we have to find out, R value. Okay, so R value we are finding, R value, R equal to V by A, R equal to V by A. So we are taking V by A here. So once again, serial number 2, 3, 1, 2, 3, 1, 2, 3, 1, 2, 3, 4. Ammeter, voltmeter, V by I form. Ammeter, voltmeter, and V by I form. So here you can observe one thing. So first you have to connect one cell, and here, so every time you are taking here, first you have to connect one cell and note down the reading of ammeter and voltmeter. So first one cell, connect one cell and note down the reading of ammeter and mention in the tabular form. Ammeter reading is current, voltmeter reading is current, voltmeter reading is potential difference, V by I is R. So Ohm's law gives the definition of resistance. R equal to V by I. So V by equal to R. So one cell I'm taking. Next we have to connect to 2 cells. So second one is 2 cells. We have to connect to 2 cells and note down the reading of. So connecting 2 cells and note down the reading of ammeter and voltmeter again. Mention in the tabular form. Ammeter and voltmeter again and mention in the tabular form. So here you can consider first you have to connect one cell. One cell you have to connect and note down the reading of ammeter and voltmeter. Ammeter reading is current. Voltmeter reading is potential difference. So you can mention the tabular form. V by I form. Okay. So V by I form. Okay, V by I form you are considering. So next one, third one is 3 cells. So 3 cells I am taking. So repeat the process for 3 and 4 cells. So you have to take the same process for 3 and 4 cells and mention in the tabular form. Mention in the tabular form. Understood? So once again you can see Once again you can see Ohm's law. Ohm's law, what is Ohm's law? What is Ohm's law? At a constant temperature, once again we will discuss entire thing. So I hope it is this one. So now Ohm's law, what is Ohm's law? The potential difference across the given metallic conductor, the potential difference across a given metallic conductor is directly proportional to current flowing through it at constant temperature. Once again, the potential difference, the given metallic conductor. So you consider the potential difference across the ends of the given metallic conductor. So voltmeter measures the potential difference, ammeter measures the current. So here I am considering the potential difference across the ends of the given metallic conductor is directly proportional to current flowing through it. Is directly proportional to current flowing through it at a constant temperature. So and physical conditions also same. Once again, so once again, if you are taking, so the potential difference across the ends of the given metallic conductor, the potential difference across the ends of the given metallic conductor is directly proportional to current flowing through it at a constant temperature. And physical conditions also same. So if the current is passing, so here I am taking, there's a statement, V is directly proportional to I, V equal to IR, V is directly proportional to I, V equal to IR. So yeah, Ohm's law gives the definition of resistance. 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 So to do the activity of Ohm's law, we have to follow materials. So we have to take 4 cells, 1, 2, 3, 4. So 1, 2, 3, 4. 4 cells we have to take. So 1.5 volts each, 1.5 volts each. Nichrome wire is an alloy of nickel, chromium, manganese and iron metals. Nichrome wire is an alloy of nickel, chromium, manganese and iron metals. Okay. So next one, ammeter, voltmeter and switch and connecting wires. So process, what is the first process to the activity? So okay, so what is the process to do the activity? First one is, first you have to connect one cell. And note down the reading of ammeter and voltmeter. Connect one cell and note down the reading of ammeter and voltmeter. Next, connect to 2 cells and note down the reading of ammeter and voltmeter. And mention in the tabular form given below. And connect to 3 and 4. So repeat the same process for 3 and 4 also. If you draw the graph for VI, so VI graph, the graph is straight line. So the graph is linear. At the same time, it moves from the origin, because because it follows the Ohm's law. So that's why it is starting from 0. Even ammeter and voltmeter reading also will start from 0. Now you are considering here. So I'm taking, if you draw the graph for V and I. So V on y-axis, I on x-axis, V on y-axis, I on x-axis. So it will be following like this. So it is the linear form taking once again. So V on y-axis, I on x-axis, V on y-axis I'm taking here. Okay, so V on y-axis, I on x-axis. If you draw the graph, it is linear. So that is for ohmic conductors. So what are the ohmic conductors? So the substances which obey Ohm's law, those are called ohmic conductors. So this is about Ohm's law, ohmic conductors. Coming to the non-ohmic conductors, the graph is V I am taking here, I am considering here. So V I am consider. So this is the curve. So like this, non-ohmic conductors. So if it is taking ohmic conductors and non-ohmic conductors. So the conductor, ohmic conductor if you are taking, So the substances are the conductor which follow Ohm's law. The conductors which follow Ohm's law. The conductors which follow Ohm's law, those are called ohmic conductors. The substances which does not follow, the substances which follow Ohm's law, those are called ohmic conductor. The substances which does not follow Ohm's law, those are called non-ohmic conductors. So this is about Ohm's law. This is about Ohm's law. Okay. So next one, we are going to the next one. Next one. So now you can see, resistance. So I'm taking about resistance. R equal to, so resistance factor depends on resistance. Resistance depends on length. Factor depends on resistance. Factors depends on resistance. Factor depends on resistance. So resistance depends on length of the conductor. Resistance depends on length of the conductor. So R is directly proportional to L. R is inversely proportional to area. R is directly proportional to L by A. R equal to rho into L by A. So rho equal to L by A. So here resistance, I am taking the resistance. So factors on which resistance depends, we can take like that also. Factors on which resistance depends on are factors. Okay, so we can write like this. So factors on which resistance depends on. So we can take here. Okay. Now resistance depends on length of the conductor. Resistance is inversely proportional to area of the conductor. R is directly proportional to L by A. R equal to rho into L by A. So rho is the resistivity here. So rho equal to RA by L. Rho equal to RA by L. So I am taking R is the resistance. So R equal to rho into L by A. Rho is the resistivity. Rho equal to RA by L. SI unit of resistance is ohm. SI unit of area is meter square. SI unit of length is meter. Once again, so resistance depends on length of the conductor. Resistance depends on area of the conductor. Resistance L, R equal to rho into L by A. So I'm considering here. Okay. So I am considering R is directly proportional to L, R is inversely proportional to area, R is directly proportional to L by A, R equal to rho into L by A, rho equal to RA by L. So SI unit of resistance is ohm, SI unit of area is meter square, SI unit of length is meter. So if you cancel it, meter get cancelled. So meter get cancelled. Then you will get ohm meter. So SI unit of resistivity is ohm meter. Okay. So SI unit of resistivity is ohm meter. Yes. So this question they will ask for 1 mark. Very, very important. This question they will ask for 1 mark. So surely they will ask for 1 mark this question. Okay. So make sure that you are practicing this one. So this question. Okay. So this point is very, very important. So this question, resistivity is ohm meter. So you can see, so rho equal to ohm meter, rho equal to ohm meter, I'm considering rho equal to ohm meter. So here R is directly proportional to L, R is inversely proportional to L, R equal to rho into L by A. So R equal to rho into L by A, R equal to rho into L by A. So resistivity equal to RA by L. So if you are taking meter get cancelled, meter get cancelled, meter get cancelled. Okay. So here I am considering SI unit of resistivity is ohm meter. SI unit of resistivity is ohm meter. SI unit of resistivity is ohm meter. Okay. SI unit of resistivity is ohm meter. Now the difference between resistance and resistivity will discuss now. The difference between resistance and resistivity. So R equal to rho into L by A. R equal to rho into L by A. So rho equal to RA by L. R equal to R equal to rho into L by A. So I'm considering. So first one is rho equal to RA by L. RA by L. Okay. RA by L. RA by L. So R equal to rho into L by A. Rho equal to RA by L. That is the first one. Coming to the second one. Coming to the second one. So SI unit of resistance is ohm. Ohm is SI unit. SI unit. SI unit. Okay, so here is second one is SI unit of resistivity is ohm meter. Ohm meter. This is about ohm meter. And coming to the symbol, third one is, so symbol if you are taking ohm, this is the symbol of resistance. Symbol of ohm, and ohm meter if you are taking ohm meter, I am taking this the symbol. So we can take like this. Okay. And coming to the next one. So fourth one if you are taking, so resistance depends on length of the conductor. Resistance. So resistance depends on length of the conductor, area of the conductor, depending factor, depends. So I'm considering this based on, so it depends on. So here fourth one, so it does not depend on, it does not depend on length and area. Length and area. Also we can say physical dimensions. Physical dimensions. Physical dimensions. Physical dimensions. And coming to the next one, fifth one. Okay. So it also depends on temperature. It also depends on temperature. So here also depends on temperature. Temperature. And here it depends on metal of the conductor. It depends on metal of the conductor. 6-1 metal of the conductor. So here also metal of the conductor. Metal. What are the metal we are using? So based on this one, it depends. So these are the depending factors. So once again you can observe. So these are all points. These are all points we are discussing. So resistance depends on. Resistance is equal to. It is a phenomenon of opposing the electric current. So resistance is a phenomenon of. So resistance depends on. Resistance is nothing but phenomena of opposing the electric current in the circuit. Phenomena of opposing the electric circuit. Okay, so resistance is the phenomena of opposing the electric current. Resistance, okay, resistance is the phenomena of opposing the electric current. Resistor is a device which is used to oppose the electric current in the circuit. Resistance Resistance is the phenomena of opposing the electric current. A resistor is the device which is used to oppose electric current. And the next one, third one, SI unit of resistance is ohm. SI unit of resistance symbol I am taking here. So I am taking here ohm. Okay. So until this, I will discuss about these 2 points. Anyway, remaining points I have written here. I placed all the points. Resistance is the phenomena of opposing the electric current. Resistance is the phenomena of opposing the electric current circuit. Resistance is the phenomena of opposing the electric current in the circuit. Resistor is a device. Resistor is a device which is used to oppose the electric current, in the circuit, which is used. This is a device. Resistor is a device which is used to oppose the electric current in the circuit. Resistance is the phenomena of opposing the electric current. Resistance is the phenomena of opposing the electric current. So here I am considering resistance R equal to rho into L by A. SI unit of resistance is ohm. So symbol I am taking. So resistance depends on length and area. So I explained that. So resistance depends on length and area. Okay. So resistance depends on temperature. Resistance depends on material of the conductor. So whatever it is material. So on material of the conductor. Coming to the next one, resistivity. Rho equal to RA by L. So a SI unit of resistivity, very important derivation. So this derivation they will ask for 2 marks. So this the derivation of the resistance they will ask for 2 marks. Okay, even definition also they will ask for 1 mark and this one, so both 1 mark. So resistivity depends on temperature, it also depends on material. But coming to the resistance, so SI unit they will ask, 1 mark they will ask. Even depends on material factor also they will ask, and the formula they will ask for 1 mark. So very important points. All are whatever I placed on the so in this table, whatever points I placed in this table, all of those are very important. So excellent points, because each and every point, so very important in exam point of view. So here resistivity is SI unit of resistivity is ohm meter. It does not depend on length and area. So that is nothing but physical dimensions. So resistivity depends on temperature, resistivity depends on material of the conductor. So resistance is the phenomena of opposing the electric current. Resistance is the phenomena of opposing the electric current. Resistance is the phenomena of opposing the electric current. Okay, so resistor is a device which is used to oppose the electric current in the circuit. Resistor is a device, so material of the conductor. Okay, so conductor in bracket you can take conductor material, so you can take conductor. Okay, conductor, here also conductor material. Okay, so what are the material we are using, what are the conductor? So based on this one it will. Okay, so I hope it is very clear to you all. So once again, this point I already said, these points are very important. Very important. Resistance and resistivity. The factors, what are the factors? So enter the table is very important. Next one, we are going to the one more point. So one more point. Okay. So next topic is next topic is next topic is so we are going to the next one more, that is about resistors are connected in series combination. Resistors are connected in series combination. So how it will be? So we'll discuss now. Resistors are connected in series combination. Resistors are connected in connected in connected in series combination. Resistors are connected in series combination. So now we are taking one resistor like this, one more, so that I am connecting to the so here across V1, this is the R1, R2, R3, across R1 V1, across R2 V2, across R3 V3. Okay, so current is flowing, so positive terminal, negative terminal, I current is flowing I, and here also current is flowing. So positive, negative, so negative, positive, negative. Okay. Now if the current is flowing, so this is the key. This is the key. From Ohm's law we can take from Ohm's law, V equal to IR. Yes or no? From Ohm's law, V equal to IR. From Ohm's law, V equal to IR I am taking. So V equal to IR. V is directly proportional to I. So V equal to IR I am considering. V equal to IR. V equal to IR. Right? Yes. So here, whatever the current is flowing throughout the circuit is same. Whatever current is flowing throughout the circuit is same. Whatever the current is flowing throughout the circuit is same. So potential difference for V1, V2, V3, potential difference for V1, V2, V3 is different. So you can observe carefully, whatever the current is flowing throughout the circuit is same. Whatever the current is flowing throughout the circuit is same. Here, so I'm taking whatever the current, so throughout R1, R2, R3, so all these three. So current is same, but potential difference V1, V2, V3, because resistance are different, R1, R2, R3. So resistance are different, then automatically potential difference will be different. Now, so Vs equal to, so from this Vs equal to, we can take IR1, IRS. So V1 equal to IR1, V2 equal to IR2, and V3 equal to IR3. So substitute everything here. So V is equal to V1, V2 plus V3. So here we consider. So V equal to, from Ohm's law, V equal to IR. From Ohm's law, V equal to IR. Vs equal to IRS. V1 equal to IR1. V2 equal to IR2. V3 equal to IR3. So from that, so I can consider IRS equal to IR1 plus IR2 plus IR3. So IR3. So we can take I common. So in this we can take I common. So in this we can take I common. So if you take I common, okay, if you take I common from this point, if you take I common, I get cancelled. So now you are saying, so I, if you are taking IRS equal to I, if you consider R1 plus R2 plus R3, R1 plus R2 plus R3. So now I am cancelling II. So II, if you cancel it, then the remaining values are that is RS equal to R1 plus R2 plus R3. So RS equal to R1 plus R2 plus R3. So this is about resistors are connected in series combination. Resistors are connected in series combination. So once again, from Ohm's law, if you are taking, okay, so if you are considering like this, from your considering, so R1, R2, R3, three resistors are connected in series combination. Current is passing from battery. Okay, this is the key, and ammeter, voltmeter, we across R1 V1, across R2 V2, across R3 V3. So current is passing. So throughout the circuit current is same. So that's why from Ohm's law V equal to IR, from Ohm's law V equal to IR, from Ohm's law V equal to IR. So Vs equal to IRS, V1 equal to IR1, V2 equal to IR2, V3 equal to IR3. So Vs equal to V1 plus V2 plus V3. IRS equal to IR1 plus IR2 plus IR3. So II we can take common, II get cancelled, RS equal to R1 plus R2 plus R3. If n number of resistors are connected in series combination, if n number of resistors are connected in series combination, RS equal to NR. If n number of resistors are connected in series combination, if n number of resistors are connected in series combination, so RS equal to NR, RS equal to NR. So in series combination, you have to do only one thing. You have to do only one simple one. So just you have to add all the resistance. If you add, that's enough. So in series combination, okay. So in series combination, we can see. In series combination, you can observe. Okay. In series combination, simply we can add all the resistance. I hope it is very clear. Just check it once. So just take one break, 5 minutes. So until resistors are connected in series combination, just check once. So yes. So welcome to the class once again. Now see. So resistors are connected in series combination completed. Now we will discuss resistors are connected in parallel combination. We'll discuss. Okay. Resistors are connected in parallel combination. How it will be? Just check once. Resistors are connected in parallel combination. So now we'll see. Okay. So I'm connecting. So resistors in this way. Hi everyone, welcome to the class. So from this current is passing. From this current is passing. So if the current is dividing, okay, so that is connected in parallel combination. So check once here. So whatever the resistors are connected, R1, R2, R3. So those three are connected in parallel combination. So the potential difference will be same. Potential difference will be same. So I'm taking here potential difference. R1, R2, R3. I1, I2, I3. So current is dividing, right? Current is dividing. Potential difference is same. Potential difference is same. From Ohm's law, V equal to IR, I equal to V by R. From Ohm's law, we can take here. You can consider from Ohm's law. So current is passing from here. Current is passing from Ohm's law. We can take from Ohm's law. From Ohm's law. From Ohm's law. From Ohm's law. Current is passing from positive terminal to negative terminal. Okay. So these three resistors are connected. Okay. So here I am considering. Three resistors are connected in parallel combination. Three resistors are connected in parallel combination. Okay. So now you can see. Hi. Hello. Thank you. Good job. So okay. So come to the point. Now we are going to discuss about. Okay. Okay, thank you everyone. So come to the point now. From Ohm's law, V equal to IR, I equal to V by R, I equal to V by R, V by R. So from this we can take current IP equal to, so because why we are taking current, so whatever the current is flowing from the battery, that is dividing into I1, I2, I3, I1, I2, I3. So that's why IP equal to I1 plus I2 plus I3. I3 because potential difference is same. Potential difference is same across three resistors. Okay, across three resistors, potential across three resistors R1, R2, R3, R1, R2, R3. Across three resistors, potential difference is same. So that's why we are taking VP equal to V1 equal to V2 equal to V3 equal to V. V3 by VP equal to VP equal to. So I am considering here potential difference is same across three resistors. Potential difference is same across three resistors. Potential difference is same across three resistors. So that's why I'm taking R1, R2, R3 across three resistors VI connected. That's why VP equal to V1 equal to V2 equal to V3 equal to V. So current, what of the current is flowing from battery. So that is dividing to I1, I2, I3, I1, I2, I3. That's why I'm doing like this. Now you can consider, so IP equal to V by RP, V by RP. So V by R1, V by R1 plus V by R1 plus. So V by R1 plus V by R2 plus V by R3, V by R3. So here I'm considering V by Rp equal to V by R1 plus V by R2 plus V by R3. So now we can take V common. So we can V common. So V I'm taking common. So 1 by R1 equal to, so plus 1 by R2 plus 1 by R3. 1 by R3. So I'm taking now. So V will get cancelled. V will get cancelled. V will get cancelled. So now we are considering V will get cancelled. I am from Hyderabad, so I completed my BTech, so mechanical. Okay, check that in my profile I have written here. So that is my profile. Okay, so now I'm considered like a 10 years experience in teaching. So VB get cancelled. 1 by RP equal to 1 by Rp equal to 1 by R1 plus 1 by R2 plus 1 by R3. So if n number of resistors are connected in parallel combination, so if n number of resistors are connected in parallel combination, so that is 1 by Rp equal to 1 by Rp equal to n by R, Rp equal to R by n. So very important. Okay, so just you can check once. You can check once if the resistors are connected in parallel combination. If resistors are connected in parallel combination, if resistors are connected in parallel combination, okay, so now you are considering here once again check once. So R1, R2, R3, R1, R2, R3. So three resistors are connected in parallel combination. So Vp equal to V1 equal to V2 equal to V3 equal to V. So here current, whatever the current is flowing, that is dividing into. So So now I am considering here R1, R2, R3, R1, R2, R3, R1, R2, R3. So the current is dividing. That's why IP equal to I1 plus I2 plus I3. Whatever the current. So if you add these three current, so whatever the current is flowing from here, that current only we will get it. That current only we will get. So that's why IP equal to I1 plus I2 plus I3. So V by RP equal to V by R1 plus V by R2 plus V by R3. So we are taking common. We can take common, we get cancelled. 1 by Rp equal to 1 by R1 plus 1 by R2 plus 1 by R3. So this is the answer. 1 by Rp equal to 1 by R1 plus 1 by R2. Okay. So now you are considering 1 by Rp equal to N by R. So Rp equal to R by N. Rp equal to R by N. Okay. This is about So one more concept is left, that is about heating effect of electric current. We'll discuss. Now heating effect of electric current. So heating effect of electric current. So heating effect of electric current is nothing but, so potential difference V equal to W by Q. So V equal to W by Q. Heating effect of electric current. Heating heating effect of electric current, heating effect of electric current. Okay, so V equal to W by Q. So V equal to W by Q. So potential difference is equal to potential difference is equal to W by Q. W equal to V into Q. So electrical power is nothing but rate of doing work. So that is nothing but VQ by T. So now you are considering P equal to V into Q by T. So Q by T is I. Q by T is I current. And P equal to VI. So energy is given to the conductor. Energy is given to the conductor. So E equal to P into T. P into T. P equal to VI and T. So we know V equal to IR from Ohm's law. V equal to IR. So E, whatever the energy is given to the conductor, whatever the energy is given to the conductor, whatever the energy is given to the conductor, that will become in the form of heat. Whatever the energy is given to the conductor, that will become in the form of heat. So now you are substituting V equal to IR into I into T. So then H equal to I square RT. I square RT. This is also known as Joule's law of heating. So heating effect of electric current is also known as Joule's law of heating. Observe here. So potential difference I am taking. So each and every line is very, very important. Each and every line is very, very important. So once observe here. Once observe here. Okay. So now I am taking. Here I am considering here. Okay. So V equal to W by Q. V equal to W by Q. Okay. V equal to W by Q. W by Q. So W equal to V into Q. So electrical power is nothing but rate of doing work. So P equal to W by Q. P equal to W by T. So rate of electrical power equal to work done. So rate of doing work. So work we know VQ. So substitute this value, VQ value. So you can consider here. So VQ value can substitute. VQ value can substitute. So I'm substituting in the place of VQ, I'm substituting the VQ value. In the place of, okay, so in the place of QI, you can substitute I and we'll get so VI, so equal to P. So in the place of P, we can substitute. In the place of P, you can substitute like this, okay, like, and V, so in the place of V, you can substitute IR. So H equal to IR into IT. So then we'll get H equal to I square RT. H equal to I square RT. I hope it is very clear to all. Very clear to all. So one check here, one check here, one check here, one check here. Okay, potential difference. So V equal to W by Q. V equal to W by Q. W equal to V into Q. V equal to W by Q. W equal to V into Q. Electrical power equal to rate of doing work. So W equal to VQ by T. So Q by T is I. So P equal to VQ. Q by T. So P equal to VI. So electrical energy is given to the conductor, that is nothing but P into T. So P equal to VI, V equal to IR. So H equal to IR into IT, IR into IT. So H equal to I square RT. So this is also known as Joule's law of heating. This is also known as Joule's law of heating. This is also known as Joule's law of heating. Heating effect of electric current is also known as heating effect of electric current is also known as Joule's law of heating. Heating effect of electric current is also known as Joule's law of heating. Heating effect of electric current is also known as Joule's law of heating. Joule's law of heating. Very, very important. Each and every line is important. Each and every line they will ask for exam in the exam, either 1 mark, 2 marks. Okay, so even problems also related to problems also this question will come. Okay, so be prepared. So prepare well, practice well. Do more problems related to this one. Do more problems because this concept is very important. Okay, so try to do each and every line is one formula. V equal to W by Q, W equal to VQ, P equal to W by T, VQ by T, Q by T is I, P equal to V into Q by T, P equal to VI, E equal to P into T, VIT, V equal to IR. So H equal to IR into IT, that is nothing but H is equal to I square RT. So each and every line is a formula. Each and every line is a formula. So try to use these formulas and practice in your exam. Okay. So do more problems. Do more problems to master in this concept. If you want to master in this concept, you must practice more problems. So this is about this is also known as Joule's law of heating. Heating effect of electric current is also known as Joule's law of heating. Next one, short circuit. Short circuit is there. Short circuit is nothing but the direct contact of live wire and neutral wire takes place. Direct contact of live wire and neutral wire takes place. Then heavy amount of current will be drawn from the mains. So then it leads to the fire in the building. Okay, then we can go to the overloading. Overloading is nothing but high voltage appliances on at a time. High voltage appliances on at a time in the circuit. So high voltage appliances on at a time in the circuit. Then high voltage appliances on at a time in the circuit. Then heavy amount of current will be drawn from the mains. Heavy amount of current will be drawn from the mains. Heavy amount of current will be drawn from the mains. Okay. So then it leads to the short circuit and firing will occurs in the home. High voltage appliances on at a time, then it leads to the heavy amount of current will be drawn from the mains, then that is called overloading. Overloading is nothing but high voltage appliances on at a time, like a geyser, washing machine, fridge, geyser, washing machine, fridge, like that. So high voltage appliances on at a time in the circuit. Okay, so then what happens? Then it leads to the it draws heavy amount of current from the mains, then it leads to the short circuit also. So that is about overloading. Coming to the next one, so there are positive cells, like you can say live wire, neutral wire, earth wire. So the potential we'll discuss now. Very, very important. 1 mark. So in the exam they will ask. Now you can see a live wire. Live wire is potential difference is 220 volts. In India we'll use 220. Neutral wire potential difference also. Neutral wire potential difference is 0 volt. Earth wire, coming to the earth wire is 0 volts. So the difference between live wire and neutral wire. So live wire is in red insulation. Neutral wire is black insulation, black in color. Earth wire is in green color. So green color. Okay. So green color. So live wire is potential difference is 220. Potential is 220 volts. Neutral wire is 0. Earth wire also 0. The difference between live wire and neutral wire is 220. So the difference between live wire and neutral wire is 220 volts. So in India, we are using 220 volts. Okay, so we are using 220. Okay, now very, very important, 220 volts. So the difference between the potential difference between neutral and earth wire is 0 volts. The difference between live wire and earth wire is 220. Okay, so the difference between live wire, potential difference between live wire and neutral wire is 220. Potential difference between live wire, neutral wire and earth wire is 0. Potential difference between live wire and earth wire is 220. So very, very important. Live wire, that is nothing but positive terminal. Actually, this is also positive terminal. Live negative terminal. Okay, this is the earth. And next one, coming to the fuse. Fuse is a safety device we are using in the electric circuit. If heavy amount of current goes, then required limit. If heavy amount of current goes, then required limit. So fuse melt and breaks the circuit. And it safeguard the appliances, electrical appliances. And coming to the earthing, heavy amount of current is there in the circuit. So extra current is there in the circuit that will send to the ground. So earth wire will send to the ground. Okay, so this is about safety measures which we are using in the circuit. I hope it is very clear to us. So this is about electric current. This is about electric current, and so everything we discussed about live wire, neutral wire, green wire, and so potential difference, electrical potential. So once again we will recall all the points whatever we discussed from right from starting. So first one is Ohm's law, sorry, first one is electric current, conventional current, and electric current. Okay, so electric circuit, electrical appliances, and next one, potential difference, electrical potential difference, and electrical potential. After that, Ohm's law, factor depends on resistance or resistivity, difference between resistance and resistivity. Next one, we are going to resistors are connected in series combination, resistors are connected in parallel combination, and heating effect of electric current. Coming to the applications of heating effect of electric current, coming to the applications, if you see applications of heating effect of electric current, yeah, electrical iron box, electrical heater, electrical cooker means, so the source of energy continuously gets dissipated entirely in the form of heat. The source of energy continuously gets dissipated entirely in the form of heat is called heating effect of electric current. The source of energy continuously gets dissipated entirely in the form of heat. That is called heating effect of electric current. This is also known as Joule's law. Okay, so H equal to I square RT. Heat produced in the conductor is directly proportional to square of current. Heat produced is not there. I already completed. Heat produced in the conductor is directly proportional to square of current. Heat produced in the conductor is directly proportional to resistance. Heat is produced in the conductor is directly proportional to time. So that is about Joule's law of heating. So I hope it is very clear. So regarding those points we discussed. And next one, like a quantization of charge, electrons will not move in a conductor 1 or 2. So there are bunch will move. That is nothing but quantization of charge, Q equal to Ne. And here one more point. So one more point I have to discuss. That is, so on one electron, how much charge is present? On one electron, how much charge is present? So that like a problem. This is also like a problem. I'll discuss now. Like a problem is like a problem we are considering. So on one electron, how much charge is present? On one electron, how much charge is present? In 1 coulomb, how many electrons present? That also problem only. Okay, so we'll discuss that one. So now you can see. Now you can see. Now you can see. Okay. So on one electron, if you are taking on one electron, so 1.6 into 10 power minus 19 coulomb. So in 1 coulomb, how many electrons are present? So in 1 coulomb, how many electrons means 1 by 1.6 into 10 power minus 19. So if you are taking up 1 by 1.6 into 10 by 10, 10 by 10 into 10 power 19. So if you solve this one, 10 by 16, that is nothing but 10 power 19. If you do it again, this one, so 0.625 you'll get 0.625. So 0.625 into 10 power 19. So then you are taking 6.25 into 10 power 18 electrons. So this is the number in 1 coulomb. How many electrons are present in 1 ampere of current? So in 1 coulomb, how many electrons are present means, so this many electrons are present. In 1 coulomb, 6.25 into 10 power 18 electrons are present. 6.25 into 10 power 18 electrons are present. So very important, very important. So make sure that you are remembering. So related to this one, problems also will come. This is related to this one, problems also will come. Okay. So that's enough for today class. Maximum resistors are in series, resistors are in parallel, and one problem I'll explain. One problem I'll explain related to series and parallel. I will explain one problem. So we'll see. So how to redraw the diagram? Now you can see. Now you can observe. So I'm taking a diagram like this. So here. Okay. So now I'm taking here like this. This circuit switch. So I'm taking 0.5 ohm, So current is passing. So positive terminal, negative terminal key. Now, so I am taking this is 2, this is 2. How to solve it? How to solve it? So now you can take from here first one while solving this type of circuit problems. While solving this type of circuit problems, you must redraw the diagram every time when you are identifying. You must redraw the diagram. So you can see. So I'm taking this 2. I'm taking this 2. So redraw the diagram. So 2 plus 2 series means 2 plus 2 you have to take. That you got 4. So again now you got like this. So 4, 2. So now this is 0.5. Again this is 0.5. So these two are in parallel combination. So these two are in parallel combination. If it is in parallel combination, so it is in parallel combination, you have to do 1 by Rp equal to 1 by 4 plus 1 by 2. So it is, if it is in parallel combination, if it is in parallel combination, we can do parallel combination. Okay. So formula, we can use the formula. 4 I am taking 1 plus 2, that is nothing but 3 by 4. So 1 by Rp is 3 by 4, Rp equal to 4 by 3. We need only Rp. We need only Rp. We don't want a 1 by Rp because finally we have to add Rp value only. So that's why. So again we have to redraw the diagram. We can redraw the diagram. Now you redraw the diagram. So this is 4 by 3 and this one is 0.5 and this one is 0.5. So you can add. So how much 1 will get? So 0.5, 0.5, 1 plus 4 by 3. That is R value because all are in series combination. All series combination means we just add simply. So 0 plus 0, 1. Now you are taking 3 plus 4 by 3, 7 by 3. So R equal to 7 by 3. That is the answer. So you can take how many times it will go? Just check once and let me know. This is ohm. Okay, 2 times 3 point. So 3 2 ja. 3 2 ja 6. Point 3 3 ja 9. So again like this it continue. 2.6 point 10 it will be 3 3 ja 9. So 3 3. So we can take 3 4 because it's a recurring. So we can take like this. 2.36 I hope. Is it correct? Is it correct? Okay. So this is my teaching aid. So when I'm teaching, so we can go with that method. That is one of the teaching. If you want to once check my videos, you can check the channel. Once again, you can check the entire channel, how it is, how I'm teaching. Then you will get it. No. So why I'm wearing this one? This is one of the teaching aid. This is one of the teaching aid of mine. So once you can check the channel, then you'll get more updates, more points, right? So one more problem. So actually, few more problems we have to discuss, but still, we have less time, so that's why I'm not going because there are so many points are there. I explained. Okay, we'll do one more problem. One more problem. So try to do this problem. A copper wire of resistivity. So we'll see now. everyday 6 p.m. Everyday 6 p.m. you have a class every day 6 p.m. for grade 11. I'm teaching already. Yesterday you can check the videos. Motion in a straight line. That is nothing but motion in 1D. I explained those topic. One check once, and also explain units and measurements and vectors and scalars. And next one, motion in a straight line, distance, displacement, velocity, speed, acceleration, equation of motion by graphical method, equation of motion by integration method. So two methods in two ways I explain those equations. You can check once in my channel. Those videos are available, live classes. Motion in a straight line, so the name is motion in a straight line. You can check. If you want every day at 6 p.m., every day at evening 6 p.m., every day evening 6 p.m., every day evening 6 p.m., you have live class on grade 11 topics. Grade 11 topics. So 11 a.m. will be their class, 3 p.m. will be there, 11 a.m., 3 p.m., 6 p.m., and 9 p.m. These are the live class timings. These are the live class timings. Once again, I'll be saying first one. So 11 a.m., 11 a.m., 11 a.m. So second one, 3 p.m. So approximately 3:30 we can take 3:30 p.m. 3:30 p.m. 3:30 p.m. and say third one 6 p.m. Third one 6 p.m. 6 p.m. and fourth one 9 p.m. These are the live classes timings. Live classes. Live classes timings. Okay. So on these classes timings, singing, teaching, checking lab. It's passion. It's a passion. Passion for teaching. More than that. That's right. So no other words. So next one. So question I will discuss. So just go through it. The question. A copper wire of resistivity. A copper wire. A copper wire of copper resistivity. A copper wire of resistivity 1.6 into 10 power minus 8 ohm meter has a cross sectional area of area of 20 into 10 power minus 4 centimeter square. Calculate the length. Calculate the length of this wire. Required to make a 10 ohm coil. So that's the question. Can anybody say this question? So if you know the answer, let me know. So actually easy only, very easy only. First you have to check once. So first you have to check a copper wire of resistivity. Resistivity is given in SI unit and as a cross section area, but here they given in a CBSE unit. Calculate the length of the wire is required. So resistance given. So now write the given data. So rho equal to given data rho equal to 1.6 into 10 power 8 ohm meter, and area of the cross section is given. So A equal to 20 into 10 power minus 4 centimeter square, and R equal to 10 ohm given, 10 ohm. So here you can observe this. One resistivity, area of the cross section, and resistance. Okay, but here only they given in centimeter square. Centimeter square they given. Remaining all are in your SI system. Only area of the cross section they given centimeter square. Now you can see. So I am taking 1 meter equal to 100 centimeter. 1 centimeter equal to 1 by 100 meter. So we are they given centimeter. So that's why. So 10 power minus 2 meter. 1 centimeter equal to 10 power minus 2 meter. So 1 centimeter whole square, if you are taking 10 power minus 2 whole square meter square, that is nothing but 10 power minus 4 meter square. Okay. So now you substitute here A equal to 20 into 10 power minus 4 into 10 power minus 4 meter square. Then you will get A equal to 20 into 10 power minus 8 meter square. So now we can use the C. This conversion is very important. This conversion is very important. Check once. 1 meter equal to 100 centimeter. 1 centimeter equal to 1 by 100 meter. 10 power minus 2 meter. 1 centimeter 10 power minus 2 meter. So centimeter square equal 10 power minus 2 whole square, that is meter square. 1 centimeter square equal 10 power minus 4 meter square. 10 power minus 4 meter square. So very important, very important this conversion. So now you can see the formula. The formula they are asking to find out length, calculate the length. So normal formula equal to R equal to rho into L by A. So L equal to RA by L, RA by rho. So R equal to rho into L by A. So cross multiply RA by rho, that is nothing but L. So L equal to RA by rho. Now substitute the values. So resistance given 10. Resistor area given, area equal to 20 into 10 power minus 8 by resistivity is given. Resistivity is how much? 1.6 into 10 power minus 8. 1.6 into 10 power minus 8. Okay. So now we can cancel, right? We can cancel this. So this will get cancelled. Then you'll get 200 by 1.6. Again 10 by 10. You'll get 2000 by 16. Then you'll get 125 meter. Length is 125 meter. That is the answer. Okay. So this is about the question. Check once. If you have any doubts, you can ask. Length equal to 125 meter. So thank you so much. Thank you so much for your joining. And if you have any doubts, you can ask. So if you like this video, please do like, share, and subscribe to Student Indie Brand. So you can check one. So copper wire resistivity is given, area of the cross section is given, centimeter square they given. We have to convert into meter. So conversion I given here. 1 meter equal to 100 centimeter. 1 centimeter equal to 10 power minus 2 meter. 1 centimeter 10 power minus 2. So 1 centimeter 10 power minus 4 meter square. Substitute the value. You'll get area of the cross section. So area of the cross section. Okay, here is the area of the cross section equal 20 into 10 power minus 8. So formula is R equal to rho into L by A. L equal to cross multiply RA by rho. So L equal to RA by rho. R equal to 10 already given here. 10 into area of the cross section is given 20 into 10 power minus here 20 into 10 power minus 8, and resistivity 1.6 into 10 power minus 8. So 10 power minus 8, 10 power minus 8 get cancelled. So both will get cancelled. So 200 by 1.6, again 10 by 10. So 2000 by 16 you'll get 125. So you'll get 125. So this is the answer. If you like this video, please do like, share, and subscribe to Student the Brand. So everyday live classes already set. 11 a.m. live class will be there. 3 p.m. live class will be there. And 6 p.m. live class will be there. And 9 p.m. also live class will be there. So if you like the channel, please do like, share, and subscribe to Student the Brand. So if you like this content, you can share to your friend. You can share to your friends and those who are studying in grade 10 grade 11, grade 12. Okay, so ask them to join to the class, attend the class, listen the class. If you have any concerns, we'll discuss. Okay, so this is about Siva sir from Student Brand signing off. Thank you. Thank you so much.